everyone, welcome to our video of Assignment 1 Physical and Inorganic Chemistry. The topic we chose was acid, base and salt. Now let's go into the video. First of all, do you know the differences between acid and base?
Acid, base, acid, base, acid, base and salt, acid, base area.
Acid dissolved in water produces hydrogen ion. H plus refers to basicity of acid. pH for acid is less than 7. Base for acid is sour salt.
Alkali dissolving water produces OH minus. Alkali is a base that's soluble in water. pH for base is more than 7. Blah blah. Base test beta.
Acid react with base produce salt and water. Acid react with reactive matter produce salt and H2, while with matter carbonate produce salt to salt water.
Strong acid, H plus high concentration. Weak acid, H plus low concentration.
It's time for the litmus paper test. For acidic solution, blue turns to red. For alkaline solution, red turns to blue. Now it's time for you to compare the differences.
Let's go to the formula for acid and base.
pH equals to negative log H plus.
pOH equals to negative log H minus. pH plus pOH equals to 40. Alkali and salt produce salt water ammonia gas. Alkali react with metal ion, produce insoluble metal hydroxide and cation from the alkali. Strong alkali,
H minus high concentration.
weak alkali.
OH minus low concentration.
It's time for the litmus paper test.
For acidic solutions, blue turns to red. For alkaline solutions, red turns to blue. ACIDBA and now you compare them.
Vinegar is one of the acidic substances used to make pick a food like pick a kimchi and pick a chili.
Base is an alkaline fashion to neutralize an acid on the teeth, so French bread smells good.
Acid. Corrosive.
Sour. So bitter.
Let me explain now. An acid is hydrogen-containing substance that is capable of donating a proton to another substance. Next, what is a base? A base is a molecule or ion able to accept a hydrogen ion from an acid. Moving into the next part, which is acid-base neutralization. Acid-base neutralization is a solution is neutral when it contains equal concentrations of hydronium and hydroxide ions. When we mix solutions of an acid and a base, an acid-base neutralization reaction occurs. Next, the following situations illustrate how solution with various pH values can arise following a neutralization reaction using stoichiometrically equivalent quantities. First is, a strong acid and a strong base will react to form a neutral solution since the conjugate partners produced are of negligible strength. The second one is, a strong acid and a weak base yield a weakly acidic solution, not because of the strong acid involved, but because of the conjugate acid of the weak base. And the third one is, A weak acid and a strong base yield a weakly basic solution. A solution of a weak acid reacts with a solution of a strong base to form the conjugate base of the weak acid and the conjugate acid of the strong base. And the final one is, a weak acid plus a weak base can yield either an acidic, basic or neutral solution. When the conjugate acid and the conjugate base are of unequal strengths, the solution can be either acidic or basic. This is depending on the relative strengths of the two conjugates. To predict whether a particular combination will be acidic or basic or neutral, tabulated K values of the conjugates must be compared. Next is neutralization reactions. This is the general format for a neutralization reaction, which is acid plus base produces salt and water. It is important to note that neutralization reactions are a specific type of double displacement redox reaction. First, we need to figure out what the reactants and products will be. The cations will switch places in the products for double replacement reactions. The element will replace the cation in the reacting compound and result in a new product for single replacement reactions. Next, we need to make sure that all of the compound formulas are correctly written based on the oxidation state of the elements involved. And finally, we need to balance the equation. As y'all can see, this is an example of neutralization reaction equation. For an example, write the balanced chemical equation for the neutralization of HCl with MgOH2. There is a hint. Neutralization reactions are a specialized type of double replacement reaction. Ooh. And there is the answer too. 2HCl plus MgOH2 equals to MgCl2 plus 2H2O. Since HCl is a strong acid and MgOH2 is a strong base, the resulting solution would be neutral. Moving on to the next part. There are some examples of acid-base chemistry in the culinary world. One example is the use of baking soda or sodium bicarbonate in baking. NaHCO3 is a base. When it reacts with an acid such as lemon juice, buttermilk or sour cream in a batter, bubbles of carbon dioxide gas are formed from decomposition of the resulting carbonic acid and the batter rises. Next example is, many people like to put lemon juice or vinegar, both of which are acids, on cooked fish. It turns out that fish have volatile amines in their systems, which are neutralized by the acids to yield non-volatile ammonium salts. This reduces the odor of the fish and also adds a sour taste that we seem to enjoy. Application of neutralization process. Neutralization process is applied on titration methods, wastewater treatment, nanomaterial synthesis, in our digestive systems, and controlling soil pH. Now, let's move to the final part, which is summary. The characteristics properties of an aqueous solution of Bronsted-Lowry acids are due to the presence of hydronium ions. Those of aqueous solution of Bronsted-Lowry bases are due to the presence of hydroxide ions. The neutralization that occurs when aqueous solutions of acids and bases are combined results from the reaction of the hydronium and hydroxide ions to form water. Finally, some salts formed in neutralization reaction may make the product solution slightly acidic or slightly basic.